this third line has a negative slope, where the first two lines, as I went over, I went up, over and up. And you always go over from left to right. So these would be positive slopes, and these would be negative slopes. So the slope is comparing how much you go up, which we call the rise, divided by how much you go over, which we call the run. So it's the rise over the run. So notice on this one, the rise is big compared to the run. And then this one, for the same run, we have a small rise. So rise over run would be a smaller number because my numerator is smaller. And then notice on this one, the rise is negative because we're going down. So when we run this amount, we're going down some point. All right? So when we're looking at the x and y coordinates, it's the change in the y. So y2 minus y1 over x2 minus x1. And that's the formula that we're going to be using for the slope. So now let's look at some points. And we're going to do this with a number of different problems so that you'll get a good idea of what the slope means. So problem number 1. Let's say P is -8, -6, and Q is 10, 5. So on this one, we can see that my slope, and it's a little m, midpoint is a big M, capital M, slope, for some reason, they use the letter little m to designate the slope. And so it's y2 minus y1 over x2 minus x1. And we're going to look at this one only with both, showing it both ways, both with the formula and then looking at it from going over and up. We'll draw it on our Cartesian coordinate system. So this one would be y, this is the x coordinate of my first point, y coordinate of my first point, x coordinate of my second point, y coordinate of my second point. So this is going to be y2 is 5 minus y1 is -6. x2 is 10 minus x1 is -8. Now, minus a negative is plus a positive, so 5 plus 6 would be 11. And 10 minus -8 would be 10 plus 8, which would be 18. So my slope here will be positive. That means as I go over, I'm going to go up. All right? So now let's look at this one on my Cartesian coordinate system. So my first point is over -8. 1, 2, 3, 4, 5, 6, 7, 8. So here's -8. And then down 6. 1, 2, 3, 4, 5, 6. And so this would be my first point. Then my other point is 10, 5. So over 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 5. 1, 2, 3, 4, 5. So that point would be here. So here's P, here's Q. So now, if I look at how far I'm going over compared to how far I'm going up. And since the formula has the y coordinate first, we'll do the rise first. So let's count how many little tick marks I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So notice that my rise is 11. Now let's count my run. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And so my run is 18. And so the slope of my line is going to be 11. It went up 11 and over 18. So that's point 1, or problem 1. Problem number 2. Says, R is the point 2, 1, and S is the point 20, 12. So again, this is the x coordinate of my first point, the y coordinate of my first point, the x coordinate of my second point, and the y coordinate of my second point. So my slope is going to be y2 minus y1 over x2 minus x1. So that's going to be the y coordinate of my second point is 12 minus the x coordinate of my, the y coordinate of my first point is 1. The x coordinate of my second point is 20 minus x1, which the x coordinate of my second point is 2. So 12 minus 1 would be 11, and 20 minus 2 would be 18. Again, we have the slope of 11/18. They're not all 11/18. Now let's look at the point T is negative 311, and S is 4, 11. So this gives me y2 minus y1 over x2 minus x1. So this is x coordinate of my first point, y coordinate of my first point, x coordinate of my second point, y coordinate of my second point. So this is going to be y2 is 11 minus y1 is 11 over x2 is 4 minus x1 is negative 3. So get 11 minus 11 is 0 over minus a negative 3 is plus 3, so 4 plus 3 would be 7. Now let's look at this one as well. Notice I'm at negative 3, 11. So that would be here. And then my next point is 4, 11. And so this one, here's T and here's S. Notice that when I go over, when I run, my rise is 0. I'm not going up or down any, I'm only going over. So a slope equal to 0 simply means that you have a horizontal line. Now, problem number 4. Let's say that A is 3, negative 2, and B is 3, 4. So my slope here, y2 minus y1 over x2 minus x1, x coordinate of my first point, y coordinate of my first point, x-coordinate of my second point, y-coordinate of my second point. So on this one, I have 4 minus 3, y2 minus negative 2, y2 minus y1. And then you have x2, which is 3, minus x1, which is also 3. So this gives me minus a negative 2 is 6, is plus, so 4 plus 2 is 6. 3 minus 3 is 0. Now let's look at this one. So over 3, down 2, and over 3, up 4. So this would be point A, this would be point B. Now notice on this one, we're not going over any, we're just going up. And so this one, the slope is undefined, because remember, you can't have a 0 in the denominator. And so the slope is undefined. All right, so let's look at this. When the x-coordinates are the same, notice the denominator becomes 0 and you have an undefined slope. On this one, where the y-coordinates are the same, the numerator is 0 and you have a horizontal line and the slope is 0. So if the x-coordinates are the same, it'll be a vertical line, undefined slope. If the y-coordinates are the same, then it'll be a horizontal line and the slope will be 0. All right, now let's talk about parallel lines. So if I have two lines that are parallel, notice that the rise over the run on this one will be the same as the rise over the run on this one. And so when I have parallel lines, so let's call this line 1 and this line 2, M1 is going to equal M2. So if I say the slope of the first line is 4, then what do you know the slope of the second line is? 4. If I know the slope of the first line is 2/3, then what will be the slope of the second line? 2/3. And if the slope of the first line is negative 1/2, then the slope of the second line will also be negative 1/2. So for parallel lines, the slopes are the same. Now, if I look at perpendicular lines, first of all, let's look at this. A slope of 0 has an undefined slope perpendicular to it. If I have this one, and I draw one perpendicular to it, notice this slope is about 1. The slope is negative about 1. If I draw this one really shallow, then this one will be very steep. And notice that all three of these are perpendicular lines. So the first thing to notice is if my first one is positive, then my second one is going to be negative, like here and here. Also notice that the steeper this line is, then the shallower this line. So if this one is very shallow, this one will be steep, or if this one is steep, then this one will be shallow. All right, so the way that this works is M1 is equal to the negative reciprocal of M2. So if I say M1 is 4, then what will my second slope be? Well, first you have to change the sign. So since this one is positive, this one will be negative. And then I need to take the reciprocal. So this is understood to be 4/1. So when I take the reciprocal of 4/1, I get 1/4. if I say M1 is 2/3, then what will M2 be? Well, first I have to change the sign. So since this one's positive, this one will be negative. And then I'm going to take the reciprocal of 2/3. So you just flip it over and it becomes 3/2. And then if I have my first one is -1/2, then I'm going to first change the sign. So since this one's negative, my second will be, my perpendicular one will be positive. And then I'm going to take the reciprocal. And so this would be 2/1. And so that is just 2. So that's how you do parallel and perpendicular lines. Now the next thing that we're going to do is we're going to look at testing for collinearity using slope. And this is way easier than using the distance formula. So if I have the points -3, 2, and Q is 1, 7, and R is 2, -5. Well, first I'm going to find the slope between these 2 points. Then I'm going to find the slope between these 2 points. And if they're the same, then it means that they're collinear, because if from P to Q has the same slope as from P to R, then they will be all on the same line. Whereas if P to Q has one slope and then P to R has a different slope, then they will not be on the same line. Notice it doesn't have to be P and Q and P and R. You could also do P and Q and R, or you could do P and R and Q and R. You just do the slope between any of the 2 points, and then again the slope between any of the other 2 points, and if they're the same, then they are collinear. So let's let this be x1, y1, and x2, y2. So my slope from P to Q will be y2 minus y1 over x2 minus x1. So this would be 7 minus -3, which would be 7 plus 3 would be 10. And then x2 minus x1 would be, I did it again. I'm sorry, this should be 7 minus 2, which will be 5. I apologize, I do that all the time. It's y2 minus y1, and then x2 minus x1. And this is something you need to be very careful about because it's very easy to do, as you've seen me do it here. So x2 minus x1 would be -1 minus -3, and so this would be plus 3. 1 plus 3 is 4. So it'd be 5/4. Now let's do the slope from P to R. So now this is no longer x2, y2. This is the x-coordinate of my second point, the y-coordinate of my second point. So this would be y2 minus y1 over x2 minus x1. So this would be -5 minus y1, which is 2, and then x2, which is 2, minus x1, which is 3. So -5 minus 2 gives me -7, and 2 minus -3 is plus 3, gives me 5. So are the slopes the same? No. So that means that we have this case where the slopes are not the same, and so they are not collinear. If the slopes had been the same, then they would be collinear. Now, the last thing in this section, we're going to look at a rhombus. I'm going to draw it first. So this is, we're going to start at the origin. So this is the point 0, 0. Then we're going to have the point over 3, up 1. So that's one side of my rhombus. Called this one S and this one R. And then over 1, up 3. So that would be here. We'll call that P. And then the last one is over 4, up 4. I'll call this Q. So 4, 4, 1, 3, 3, 1. All right, so there is our rhombus. Now, the first thing they want me to show is that the line PQ is parallel to the line SR. So is PQ line segment parallel to line segment SR? Well, how can I tell that? Well, if the slopes are the same, then the lines will be parallel. So, first I'm going to find the slope for M1. So this is going to be X1, Y1, X coordinate of my first point, Y coordinate of my first point, X coordinate of my second point, Y coordinate of my second point. So this would be Y2 minus Y1 over X2 minus X1. So Y2 is 4 minus Y1 is 3. Divided by X2 is 4 minus X1 is 1. So this would be 1/3. So the slope of this line is over 3 up 1. Now let's look, and this is from P to Q. Now let's look at the slope of the line from S to R. So now this would be X1, Y1 and X2, Y2. X coordinate and Y coordinate of my first point, X and Y coordinate of my second point. So this is going to be Y2 is 1 minus 0 over X coordinate of my second point would be 3 minus X1, which is 0, which is 1/3 as well. So these two are equal, so that tells me that the lines are parallel. Now, the last thing they want us to do is they want us to show that the two diagonals are perpendicular. Okay, so to show that the two lines are perpendicular, again, we're going to use P and R